Alright, so today we're going to talk about diagonals and how they relate to interior angles of a polygon. Now diagonals, I already have written up here, is a line segment that connects two non-adjacent vertices. So for example, the square I have drawn here, the diagonal would be from one vertex, which is a corner, to another vertex that's non-adjacent. So like this corner could not connect to this corner or this corner because those are the two adjacent vertices. So if you take another corner, draw another diagonal, so a square has two diagonals. The pentagon here, take one corner, you draw a diagonal to a non-adjacent vertex. You do the same for each of the corners. You end up with 5 diagonals. So you have 2 diagonals, 5 diagonals. And now a triangle is a little different because if you take one corner, there's only 2 other corners to connect with, but they're both adjacent. So that means that a triangle has 0 diagonals. And what we want to do today is to determine a way to find the sum of a polygon's interior angles. So we want to find, what the sum is of this angle, this angle, this angle, and this angle. And now a square, we know that each angle is 90 degrees. So if we have 4 90 degrees, how much is that?
360.
360. So we got 360 degrees here. So if we do the same for the pentagon, we have this angle, we add up all 5 angles, we come up with 540. But to figure that out, instead of using, because unless you have a protractor, you have to measure this, otherwise you might not know which each of these angles are. So we'll take the square again, for example. If we use diagonals to figure out what the interior angle sum is, we draw one diagonal across. Now we've made 2 triangles, and we know that each triangle has 180 degrees, and if we have 2 of them, that equals the 360 degrees, which is the sum of the interior angles. If we do the same thing for the pentagon, we have a few diagonals, and now we've got 3 triangles, which each equal 180 degrees. So we have 180, 2 180, that's 360, another one that's 540. And we don't have to worry about the triangle because they don't have any diagonals, and it's already 180. So we could do it that way, but that's fairly simple. So what if we have a shape that looks like this, and we have all these different sides, and I don't know what angle that is, and if we did the same strategy that we did over here where we draw diagonals and make triangles, you could do that. It gets a little messy. It gets a little messy, and it's hard to keep track of where the lines are. So instead of doing it that way, draw a shape. And I have an octagon, 8 sides. Now if we put a point right in the middle, anywhere in the middle, and we can make triangles out of this. So now we have a bunch of triangles instead of measuring each angle individually. And we still know that each triangle equals 180 degrees. We should have 8 of them, because there's 8 sides in an octagon. Alright, so we have 8 triangles because there's 8 sides in an octagon. And we have 180 times those 8 sides. That comes out to be, I'm not sure what that is, so whatever that is. Now each triangle, this 180 comes from this angle what's this angle, what's this angle? This 180, the same thing.
It's 1,440.
1,440.
440. Yep.
Alright, so we have that's the 8 triangles added together, but we're trying to find the interior angles of this whole polygon, the whole octagon. And this angle right here is not included in the exterior or the interior angles. Neither is this one or any of these inside of each triangle. And that circle, or the shape in the middle is a circle. And how many degrees is in a circle?
360.
360. So this answer, we have to subtract that 360 degrees because each of these angles, which sum up to be 360, aren't included in the total exterior or the total interior angles. So the 1,440 minus the 360 would be 1,080.
Yep.
1,080. So that would be your answer. Now we can do the same thing for any polygon, not just an octagon or a pentagon or a square. So if I erase some of this. Right, so if we take into account that each time that we draw those diagonals, we have 180-degree triangles in there. And then we multiplied it by, what did the 8 represent? That represented the number of sides in the octagon. So the number of sides can be represented by n. And then we subtracted the 360 because that was the circle in the middle of our octagon. So we can use that equation to find what the sum of the interior angles of any polygon is, and if you simplify it, it comes out to be n minus 2. Both of these equal the same thing, so for any polygon, you can find the sum of the interior angles with that. Are there any questions?